What I do? Oh my goodness. What was 15? 15? You can say I thought we did 14. All right. I'm gonna run through these quickly. If I go too fast, tell me. I'm gonna just start zooming. This is 14. Oh my gosh, I didn't take it till now. The thing I'm looking at here, or what I recognized here, and I hope you recognized as well as we do these, that the perfect square on the bottom is 1 plus a perfect square. So I'm thinking this is going inverse tan, inverse tan route. So if I let u, and we had mentioned letting u be 9t, but that doesn't really work because if you square 9t, you get 81t squared. So we have to let u be 3t, which means du will be 3 dt. So I need to counter with a 1/3 out here. So that I have 1/3 times the integral, negative 1/3 to 1/3, 1 over 1 plus u squared d. Because 3t squared is 9t squared. All right, so this gives me 1/3 inverse tan of u from negative 1/3 to 1/3. Now, if I leave the u there, I need to adjust the bounds. Or I can plug in 3t here and not adjust the bounds. It doesn't matter to me either way you do it. I always adjust the bounds, but you can do whatever. This would be 1 and negative 1. This is the one where we were a little confused yesterday, and okay. Yeah, you'd still end up here. You'd still end up at this point. If you get inverse tan of 3t, if you put in a 1, you get tan 1. If you put in a negative 1, you get, yeah. All right, so because inverse tan runs from negative pi over 2 to pi over 2, so from here this way, that's the restricted domain, yes. Yes, that's restricted, and that's always the domain on inverse tan. You just have to know it, unfortunately. All right, so where is the tangent 1? Well, that one's easy because that's pi over 4, right? And then it says where is tangent negative 1? Well, that's here, which is 7 pi over 4. But if we use 7 pi over 4, 7 pi over 4 is not in our domain, right? If I have to be between these two values, 7 pi over 4 is bigger than pi over 2. Does that make sense? So instead of calling it 7 pi over 4, I'm going to call it negative pi over 4. Because that is in the domain. Well, because 7 pi over 4 is bigger than pi over 2. It is, but my domain is not. This is actually 3 pi over 2 if I go counterclockwise, right? No, I'm talking about the tangent values are going to lie between these two, but it's got to be negative pi over 2 to pi over 2. Okay, I've got minus negative pi over 4 times a third. This would be 2 pi over 4 times a third, which is pi over 2 times a third. Okay, because yes. This is my range of numbers that I have that inverse tan can be, right? 7 pi over 4 is going to be all the way over here. Right. Because it's a it's a coterminal angle, right? I can name them different ways. This would probably be a non-calculator. But now sometimes they'll give you some of these on a calculator. One maybe multiple choice on something like an inverse trig. They're not heavily tested. Not the inverse trig ones. You have to use a value that is in that. But if it was, then yes. I'd have to. Yes, but it's not going to be an inverse tangent. All right, that's 14. On to 15. 15 wasn't as hard. That was kind of a quickie, I thought. I got 2. What'd y'all let be u? Same. Du would be 2dx. I need to counter it with a 1/2 out here. So I've got 1/2, 0 to 4 of, I'm going to go ahead and make this u to the negative 1/2 du. So I don't. What? Not if it's definite. If it's definite, you don't need the plus c because you're plugging in the bounds. All right, so I got 1/2 times, if I add 1 to that, I got positive 1/2, right? And if I divide by positive 1/2, that's like multiplying by 2. So I got 2u to the 1/2. And I'm going to adjust these bounds based on my u. Two times 0 plus 1 is 1. 4 times 2 is 8 plus 1 is 9. They come out to be nice little perfect squares. 2 times 9 to the 1/2 minus 2 times 1 to the 1/2. 1/2. 6 minus 2. 1/2 of 4, which is 2. I can't believe I forgot to post these. 16. We did 16. Do y'all still need 16? Negative 1/2, yeah. We did that together yesterday. Okay. 17, I got 1/2 times 2 minus root 2 over root 2. I just didn't simplify, though. You got what? Yeah, that's how, if I simplified mine. Yeah, okay. No? Okay. Okay, we'll come back to that one. This is 18. Y'all thought this one was hard? I don't know if I got it. I got one. How do you find it? 1 over cosine. So it's just the reciprocal of cosine. Yes. Yes. So y'all don't need this, or you do need this? Okay. Of what? What to make your u? Okay, so if you tried to make it x, if you went through and you said, okay, I'm going to let u be x, that means du is what? 1 dx. I still have this in my problem, so I know that that didn't work. Well, because then you'd have ln u, right. And I can't take the antiderivative of that. I'm stuck. So I'd go back and say, okay, what if I made the other one the u? Would I have enough to be able to rewrite it and evaluate it? And if that's the case, then yes, because now I just have the integral from 1 to e, of u du. Okay. 1/2 u squared evaluated from, and I'm gonna go ahead and adjust because these are easy. Natural log of e is 1. Natural log of 1 is 0. So I just end up with 1/2 times 1 squared minus 1/2 times 0 squared, which is 1/2. Antiderivative of u. It would be the integral from 1, it would be 1/2 log x from 1 to e. Oh, 1/2. She said, what if you hadn't adjusted the bounds and instead, yeah, you just plugged in. You still get the same, yeah, it's 1/2 log e minus 1/2 log 1, which is same thing. Yeah. Night.
I got 0.7. I got 2 minus 1/2.
Let's do it. This one? I got 4 root 2 minus 4 over 3, but y'all did decimals and stuff simplified. I got 4 root 2 minus 4 over 3. All right. Did we all make u x cubed plus 3x squared plus 4? Which means du is... Oh, sorry. What did he say? Was he being a jerk? Oh my gosh. I need a 3. Yes. I was feeling this needs to be doubled all the way through, so I'll counter that with a 1/3 here. All right, so I got 1/3 the integral of 1 over the square root of u. Is it? Oh, that's why I didn't see that little key three. What? Well, clearly my answer is going to be wrong because how did I miss that whole 3? I'm really starting to think I need some reading glasses. Okay.
Why does so you get 3x squared minus 6x? Does that matter?
Supposed to be a plus. Okay. All right. Add 1. I get 2/3. So flip it 3 over 2. 2/3. I'm going to go ahead and adjust my bounds here. 1 becomes, did y'all get 4 and 8? Okay. I think so, but that's up to you. You're still doing the same thing. It's just you're doing it off to the side and then coming back, so it doesn't matter. Mm-hmm. All right, 8 to the 2/3. Oh, this is way easier than I had made it. Minus 4 to the 2/3. Why did I do what? Well, 1/3 times 3/2 would be 3/6, which is 1/2. Just a little shortcut. All right. So this is 4 minus, I can't simplify that, can I? I could simplify. I could do the cubed root of 16. I could do 8 and 2. 2 cubed root 2. All right, so then if I distribute that half, right, I could have 2 minus the cubed root of 2. Or, yeah. What's the third root of 8? I'm walking you through it, though. What times itself 3 times gives you 8? The bottom. Yes, yes, Robert, to answer your question, yes. 8 to the 2/3 is 4. I heard. I don't know. What? A half of 2 is 1. See? Well, I didn't see the whole cube root, so. No, you don't. Do you really?
Yeah, I want 100.
Oh, yeah, Stacy, solve all the math department problems. I'd split this up into 2 if I'm doing this one, of course. And I'm going to pull that 2 on the outside, too. What's your side, Brian? You still need me to work this one now that you know to split it up? Just do it. What's the antiderivative of sine x? All right, Carter, this one's yours. Not on this one, no. You don't always have to do U sub, right? If it sits there. Well, this one, Carter, what would you make U? Yeah, what? Oh,
U.
Yeah. 2x, right?
Oh.
Which means du would be what? 2. Yeah. So I need to counter it with the 1/2 on the outside. Huh? All right, I'm going to go ahead and, so this one's easy, right? Negative cosine of pi minus negative cosine of 0 plus 1/2 antiderivative of sine, negative cosine. But I do have to adjust my bounds here because remember I got a u in here. So I'm just doubling all. Okay.
Oh, I thought we weren't.
We didn't use sub on the first one, but for the second one we did have to use sub because there's a chain there, right? Cosine of pi, what is it? Oh, what? I adjusted my bounds because u is 2x, so I doubled them. Yeah. All right, what's the cosine of pi? -1, but it's negative here, so it's going to become positive. Cosine of 0. Two pi minus negative cosine 0. All right, so I got 4 up front plus, what's cosine of 2 pi? We just did that, didn't we? No, we didn't. 1. So it's -1 cosine 0. That's just gone. It's just 4. Did y'all get that one right? Bless up. I'm not even sure that I should do.
If you would have just forget them and move on, we'll agree to do that.
Let me do one of them with you. One. 22 is easy, yeah. We'll do 22 and then pick one of the harder ones. We'll do 22 and then I'll do one of the hard. All right, 22 from 4 to 19, f of u du equals 10. And then it says, what's the value from 1 to 4 of x times f of x squared plus 3 dx? I did the exact same thing. I said, well, I see an f of u here. So what if I just came over here and said u was x squared plus 3? That means du would be 2x dx. So I've already got an x. So this is, I could counter it, right, and give it the 1/2. So then I'd have 1/2 times the integral from 1 to 4 of f of u. Because, yeah, I countered I already had an x in there, right? And so then I went, okay, but wait, I have to adjust the bounds because I'm using u. So the bounds adjusted based on my u here, square it and add 3. This would become, you tell me, 19. This would become 4. So it's just 5. That's exactly right. Because look at what I started with. It told me that the entire integral was 10. The only thing different is that I'm by half. I'm sorry. Sorry.
So basically you're solving it when you get to that.
I did a U sub, so I let this.
Oh.
This is the same.
No.
Yes, it is. Other than this. So it's 1/2 times 10, which is 5. So says Carter. Yes. Well, I adjusted them based on my U. So instead of 1 to 4, it's going 4 to 19. Yeah, they're kind of new. I don't know. It should be. 12? Yes. I'm getting lost in everything. Oh my gosh. If 12's the one I did on the back, that's my 12. 12 was super duper hard.
You take 5 central. No, he takes 5 central by 3. And
Yeah, he's gonna get like 5 and all of them. Yeah, he's gonna get like the lucky.
Let me not do 12. Let me do 11 instead. I think I'm going to lose you on 12. I think I'm going to lose a lot of you on. Alright, cool. I'm going to do this one, and then we're going to move on to some Diffie Hughes with separation of variables. This is hard. The very back. I'm not, just skip, if you would like to see my work for number 12, I will let you, I worked it on the back here because I didn't have enough room. I messed up and then I had to get back and do it. This one took a lot of thought. It took a lot of thought to get it there. This one takes thought too to get there. It's just not quite as difficult as that one, but it's still pretty hard. All right, so if I look at this, I can't do a U substitution on this one like it is Y. It's bottom heavy, and if I tried, I'd end up with a 2x minus 6. I don't have that. I can't give it an x. So I'm on to another option. I can't divide because it's not top heavy. So I'm going to try to complete the square and see what happens if I can get it into looking like an inverse trig function. I'm going to go ahead just because I always take that out if I have it. I'm going to go ahead and take that 16 out, put it on the outside. I'm going to do 1 over, and I'm going to complete the square here. What c do I need? 9. I've got this plus 25, so I'm going to subtract it over here. So I end up with 16, 1 over x minus 3 squared plus 16. Everybody okay? A squared plus 2ab plus b squared. That's actually plus or minus b squared. Okay, so now I'm starting to see what it's kind of looking like, right? I'm thinking I could manipulate it to look like an inverse tan. Do you see that? Inverse tan, remember, is the x squared plus 1. Yes? I need to get rid of the 16. Do you agree? How do I get rid of it? Well, what if we just factor it out? You can't subtract it. It's still got to be a plus 1 there.
Well,
if I take it out, I don't have anything here for it to give, so I put a 1 over 16 in front, so that should I go back and distribute, it would be 1. I told y'all this one took thought. Okay.
Okay, I get what you're saying.
Yes, I'm backwards distributing, right? That's what factoring out means. I have to have this one to be a 1 in order for this to be inverse tangent. How do I make it be 1? I need to divide by 16, right? But I can't just divide that by 16. I have to divide everything by 16. Yeah. They will. Yep, they will. All right, but do y'all see how I got that denominator? Okay. If you can get that denominator, the rest of it is going to make sense, okay? So I just put it there. All right. The 16s cancel. These two 16s cancel. One's on top, one's on bottom. All right. Your goal. Yeah. You didn't listen? Listen to Carter, man. He knows what he's talking about. All right. Remember, I need tangent, inverse tangent is u squared plus 1. Do you see what I could make my u be now? More than just that, though. What, you're close. When I square it, it has to end up back where I was. So if I square my whole u, I end up with 1 over 16 times x minus 3 squared. Because that's what inverse tan looks like. U squared plus 1. I don't always either. These are hard. In the very beginning, I saw, once I completed the square, anytime you complete the square, you're looking at one of those inverse trig functions. And this, I said, can I make it be u squared plus 1? Is there some way I can do that? All right, so that means du is what? 1/4 dx. Okay, let me take this off because that's not part of u. If I distributed this right, it'd be 1/4 x minus 3/4. What's the derivative? 1/4. Now, I need all of this needs to be u squared. This piece is already squared. This one's squared too, so I had to take the square root of it. Because if I say that this is u squared, that means everything that is u has to be squared, and I have to end up back here. If I'm using inverse tan. And because it was squared to start with. This is hard. I know this is hard. Not this hard, no. The possibility may be a multiple choice question. No. I've never seen an ever. It could. I need to counter it with a 4. Because my du is 1/4.
I don't understand how you got the 4 out there. Yeah.
All right, you don't understand how I got what?
You get the 4 on the outside.
All right, if my du is 1/4 dx. I don't have that. So if I give this a 1/4, I counter it with the 4. Okay. Now fill in your u, and you can see that it's d. It's d. Did any of you just guess d?
Yeah, I did because it was on
I didn't.
Terrible, I'm sorry.
Are y'all allowed to have your
This Montgomery walked in and was like, the last one, he was like,
It is. I didn't know. I was thinking
that song always comes. It's like it's literally all what I'm really listening to.
All right. You probably won't even realize you've been gone.
He doesn't mark us party.
Solve the differential equation given the conditions. Would you say 1? Solve the differential equation. So solve it for y. At the end, you should have just a y. This might have been the day you weren't here. So yeah, remember, okay, this is going to be dy dx equals x squared y squared. Okay, and this is where we get all the y's and the dy's on one side, all the x's and dx's on the other. Okay, all right. So I'm going to start by multiplying both sides by dx. Y'all okay there? dy equals x squared y squared dx.
He's been calling that the whole time. You haven't even heard
I haven't. Y'all don't remember the differential equations? You just don't remember how to do it. Okay, so yeah, this is where once we get it separated, and before we didn't have any y's in there too, and so it wasn't quite as hard to get them separated this way. I think it must be y. But here, if I need to, I need to make sure all right, y'all get the y's with dy on one side, everything else on the other. So if I need to move this y squared, divide it by y squared, right? So I have, we did.
Why do we want the y?
Because I'm going to integrate on both sides to get rid of the dy and the dx. All right, so I get the y's with the dy, everything else on the other side, and then I integrate. Crazy, crazy. So when I integrate here, what's the antiderivative of dy over y squared? That's if it's dy over 1. Negative is similar. Dy over y squared is the same thing as if you add 1, you get negative 1, right? Negative 1. So negative y.
What is the inner one?
Dy over y squared is the same thing as y to the negative 2 times dy.
All right, hold on. I do not know what you're doing. But how did you turn the x to y?
Where are you seeing that?
Y over y squared equals y to the negative 2. But it was equal to x squared.
I was just coming over here and showing you that if you don't understand how to find the antiderivative, this is just this, yeah. Okay. What's the antiderivative of x squared? This is an indefinite integral, so I need to do the plus c. I did the antiderivative. I was just saying that you could change it to look like that to help you find the antiderivative. No, I'm sorry. Dx what? Well, it always does when you take a derivative. I mean, whenever you take an integral. Okay, but I'm not done. Why am I not done? They gave me, one, it's not y, and two, they gave me an initial condition. I need to plug it in and find c. Yeah, it's kind of what we already did. Yeah. No, it's not. Well, you'll see how this is a little bit new in just a second. All right, so we said 1 and 1, right? So negative 1 to the negative 1 equals 1/3, 1 cubed plus c. Yep, so negative 1. So I'm going to make it a fraction whenever I say negative 4/3 equals c. What is my, okay. Because that's my constant of integration. Whenever you take a derivative, right? If you have a constant on the end, what's the derivative of a constant? 0. So there could be any random. Because I was asked to solve this, tell me if this happens, what does y equal? No. When y is 1, what's the equation there, though? And that's what we're trying to find. We're solving for y. Yes. I think we did those really hard problems, and now y'all are looking at this going, oh my gosh.
No, I've never done this. I don't.
Almost. -1 minus 1/3. You did -1 minus 1/3. Which is no fun. All right, my equations so far. -y to the -1, 1/3 x cubed, and now I replace my c. I'm still not solved for y, so I still have an issue.
You literally did.
Why? That is why though.
Not by itself. Divide by -1. No, it's not.
I'm not doing
I'm not doing it.
I'm gonna switch this order, y'all. Don't freak out on me here. All the signs are changing. So instead of saying negative plus 4/3, I'm gonna say 4/3 minus 1/3. You could. I got to get rid of the -1x back. So think about. Okay. I am going to. You can think about this one of two ways. You could flip both of them over because this is really 1 over y, right? So I could just flip both of them. If that doesn't make sense to you, you can just raise both sides to the -1. And I would get y equals, and I'm okay with you stopping at this point and leaving it this way. Or because they both have the same denominator, you could write this, and if this was a multiple choice question, this is what they would do. 4 minus x cubed over 3. And then if you flip it, it becomes 3 over 4 minus.
take that and put it on the other side.
Well, I didn't. I raised both sides to the -1, so yeah. But,
No.
kind of.
But if you raise it to the next one, that 1 over 1. I would just leave it.
Yeah.
So what did it give me? What?
So she raises it.
Your directions are solve the initial value problem, solve for y. Okay? Here's what you got to do, and I'll do another one with you. It's the intro to the lesson. It's just the first 10. I will do one of them with you.
Why is Daddy Logan on the board?
I don't know. There should be a cap on them.
So he did 12 in a year.
You'll get burnt out. Yeah. I remember.
He said he's graduating from the sixth.
I'm a registered substitute. What? I'm a registered.
Yeah. You pick.
What? No.
You're ready.
I'm ready for stuff.
That was your.
Wait,
All right.
is there even more than 30 countries?
I mean, you can take different photos.
I'm gonna go ahead and separate the variables here. I'm gonna multiply both sides by dx.
All I need is money. I'm not gonna make fun of him.
He is saying right now.
He's second?
Yeah.
No, he's
What? How? No, he told me he was number 2 the other day.
It's 21.
Damn.
Have you heard that?
I'm about to
The
make
average is over 100.
Dude, how you spending this?
But he also wants an associate.
Kind of hard in how you have to think about it.
Oh, I know not to.
All right. If I listen, Linda. If I want to separate the variables, remember what I told you? The x and the y have to separate. The problem here is, look, you've got an x and a y in the. You've got an x and a y in the exponent, right? I've got to get them separated. This is a common technique that they use that you have to remember. It's gonna, the first time you see it, you're gonna go, oh my gosh, how am I supposed to know that? How are you going to separate those two? You're close. You're really close. This is actually a property of exponents thing. So if you've got e to the y plus sine x, right? When do you add exponents? When you multiply with the same base. So would you, this is e to the y times e to the sine x. I could separate them that way. But I have to think about it in terms of those exponent properties. So really this is going to be dy. And remember, I'm doing this because this is called separation of variables. I have to get the variables separated. All x's on one side, all y's on the other. So now, because it is separated, oops, that's exactly right. Oh, Stacy. I think I need a new one of these little pens. Yeah. Now I could divide by e to the y. Yep. And I would even write it instead, yeah, to help you see what's going on. E to the negative y dy. And I'm doing this in way more steps than what you really have to, just so that you really see what's going on here. That's fine. All right, I'm ready to integrate. Yes? Okay. Okay. 1, 2, 3. Just kidding, just kidding, just kidding.
I think this would be a good, like a good topic to have a project on.
How are you going to do a project on separation of variables?
Well, not specifically this.
Give us like 10.
You can like make like Lego bricks.
Legos.
Oh yeah. Is this tomorrow or over the?
Probably make it do Monday. E to the negative y. How do I do antiderivative here? But you got to counter it with, because if I think about it, u is negative y or negative x, then du would be negative 1 dy. I need a negative in there, right? So it would be negative e negative y equals. Okay. Okay, let me come over to the side with this e to the negative y dy. If I let u be negative y, we've done, yes, yes. Du would be negative 1 dy. I need a negative. So now I've got negative integral e to the u du, which is negative e to the u, which is negative e to the negative y. Y'all tracking with me now? We're in the hard stuff now, y'all. Don't get not been in hard stuff. Let's just keep going.
Yes, we do.
Antiderivative of the right side. I would probably let u be sine x, which means du would be cosine x. So I have the integral of e to the x dx, which is just e to the x, yes? Okay. Yeah. Yeah, sorry. All right, what do we do when that happens? Well, the first thing I'm going to do is solve for C. You are? Good for you.
Yeah. But why did you find X not? All right. But I didn't think it was the derivative. Oh, it's just.
Are we all together?
Yeah.
Okay.
Well, why would we not add a C on the left side?
Because adding a constant, if it's a constant, if you add it on both sides, it really doesn't matter because you don't know what it is. You just need one. All right. What was my initial condition? Yes. All right, so now I need to do negative e to the 0, sine 0. That initial condition? That's right, because we're solving for C. Well, Stella did pick the hardest one.
I wrote really big because I'm not like.
Y'all are welcome. What's the sign of 0? It is. It's number 7. What does C equal? No. -2. I'm almost there.
Oh, we gotta we gotta get Y by 2.
How in the heck am I going to get y by itself? I am going to do an ln. Before I do ln, I'm probably going to take care of that negative first, though. Divide by negative. They're not all this long, I promise you. Most of them are 1 through 4 are super easy. 5 is still easy. You won't FOIL it out. Just leave it as is, and you'll see what I'm talking about. 6 is easy too. They don't get hard until 7. 7's hard. 8's not hard if you remember your exponent properties where you add and subtract. Yeah, that's dividing. 9 is just like the one we did together, but a little bit easier. 10 is hard. 7 and 10 are the 2 hard ones. If we have time, let's see. All right, so e to the negative y equals, and I'm going to flip this order up again just because I hate to start out with a negative. It's not wrong if you put negative e plus 2. I'm just don't like it. All right, here's where it starts to get dicey. Y'all were right in that I need an ln, right? If I do the natural log on both sides, okay, that takes out the e on the left, so I've got negative y equals, yep. As long as the base is e, it just equals whatever the exponent is. I would just keep it exactly like that. And now, yes. Divide by negative. It just, Yes, because you got to get y by itself, right? So it's just negative of all of this. I guess it didn't get dicey. Sometimes it does. The argument can't be negative.
Do we have to make the equation?
Thank you. That is the equation. That's it. It asks you for domain and domain restrictions. Do not worry about that right now. Great goodness. Just do the... That's a good one. Bug it out. If you want to start on 1, go ahead and start on 1. I'll work through this for those that want this one. Oh, this one's not hard. You're fixing this, you'll see why I say that. Okay. I need to get that 4 root y on the other side. So I'm just going to divide by that. Or maybe I just divide by root 4 and leave root y and leave the 4 over there. It doesn't matter which one that goes in. It's a constant. Okay, so I'm going to come over here and I'm going to say dy over root y equals... It's still there. It's still there. I just left it on the other side. If you put it over here, that's fine too. This one's a lot easier than the other one, actually. Well, because I'm just multiplying straight across, I just divided by that on both sides. We're ready to integrate, right? Now, the reason I said this one was easy is we just did the right side of this in our homework. We did that, the integral of log x over x, because this was the one where you said, why can't I let u be x? Why does u got to be log x? Remember? Yeah. So if I take, and I'm going to come over to the side over here and work it. If I do the integral, I'm going to take the 4 out, and I have log x over x dx. Okay? If I let u be log x, and I'm going a little bit faster through this one because we just did one exactly like this. It just didn't have the 4. So this would be u du. 4 times 1/2 u squared. Four times a half is 2. And then I've got ln x squared. Don't forget plus c. The other side, that's the side that I'm kind of, eh. But I just did that one too earlier because this is really y to the negative 1/2 dy. So add 1 and you get what? Positive 1/2, right? Negative 1/2 plus 1. So times 2, that's right. There you go. 2y to the 1/2. Yep, or 2 root y. Either way you want to do it. Plug in my initial condition and solve for c. What was the initial condition here? 1 and e. Yeah. Y'all are all running ahead of me now. I hear all your pencils just a-going. Oh. It has, I'm sorry. It is 0. I got 0. So,
We gotta find out.
almost, huh? Yes. This one wasn't hard. It was just a lot of steps, but it wasn't hard. What do I do first? Divide by 2. That's nice. Everything to the second power. What does?
I'm a step behind you.
Oh, he's talking about the 2y. Mm-hmm. Y'all keep asking about what's on the exam and what's not. I have seen maybe like once every 2 years, they'll throw on one FRQ that the full FRQ is based on separation of variables, but you get all your points you get in this work right here. Like, seriously, like 6 out of the 9 points come in and did you separate the variables? Did you solve correctly? Did you plug back in? Did you find the constant of integration? Did you?